Imagine this. You're walking down a dark corridor, nervously prodding anything that looks even somewhat off. This run, you've gone deeper in the dungeon than ever before. Tensions are mounting and you are sweating. Just a little bit more gold. A teeny amount and you'll be stronger. But even then, this place would be difficult. Just then, a buddy tries to break the tension. He steps forward, starts to make a cheesy joke. It works for a moment, until he takes a step too far and finds half his body buried in a substance nobody previously saw. Pure panic sets in as his face and arm begin to visibly dissolve in the translucent space. The tension is once again broken as your mother calls you upstairs to eat dinner. She made enough for your friends too. This wasn't a terribly uncommon scene among kids back in the late 70s and early 80s. The feeling of terror only amplified due to Dungeons & Dragons being a dungeon crawler with some very punishing mechanics at this point. The Gelatinous Cube was specifically made by the creators to capitalize on the dungeon crawler setup. These days, the Gelatinous Cube's function hasn't changed despite the evolution of the game itself, yet it remains a staple of Dungeons & Dragons, and it still capitalizes on the weakness of an unprepared adventurer. Like many players, I quite like the Gelatinous Cube, finding it a fun encounter to throw at my party or to have it thrown at me, and finding it a rather cool creature in and of itself. However, my TISM senses start tingling when I look at the Gelatinous Cube. I wonder how viable it is in real life, some potential equivalents, and, well, I'm getting ahead of myself here. This video is asking a particular question, but to answer it, first we must know the Gelatinous Cube, also called Athcoid, stands out as one of Dungeons & Dragons' most iconic monsters. First unleashed, though in name only, by the legendary Gary Gygax in the original 1974 OD&D white box set, and later reappeared, now with stats, in the supplement Greyhawk the following year. The Gelatinous Cube wasn't based on any pre-existing myth or folklore, but from a clever game design perspective. A cube of transparent ooze, perfectly shaped for the standard 10-foot dungeon corridors, would catch any would-be adventurers off guard, with them walking headlong into a wall of nearly invisible living acid. Since its introduction, it's appeared in nearly every edition, inspired mythology, and even turned up in mainstream media, from The Simpsons to Disney's Onward, and of course, Dungeons & Dragons' Honor Among Thieves. But that's all preamble, and you're here for the real stuff, aren't you? So now to seriously ask what the Gelatinous Cube is. The Gelatinous Cube, as its name would suggest, is a cube that is gelatinous. Shocker, I know. Though for real, it is a translucent, semi-solid cube measuring 10 by 10 by 10 feet and weighing around 10,000 pounds. Around half as much as your mom. Some cubes can be larger, even up to lake-sized, though only one such specimen is known. And though the Gelatinous Cube is called that, it can take the shape of a container, meaning you could, theoretically, have an Indiana Jones Boulder Run sequence with a gelatinous sphere. Yeah, my condolences to any players who've had that unleashed upon them, and for DMs who wish to unleash a gelatinous sphere, please give me credit for my totally original idea. I need the views. On a more serious note, gelatinous cubes, as they were first introduced, were significantly scarier, in my opinion, than they are now. Older edition players, or those who have read up on their monster lore, would know that up until 3.5e, gelatinous cubes could induce paralysis on their attacks, as their body fluids penetrate the skin and stop a creature from moving, allowing for easy eating. Note, 4e had a different condition, immobilized, that the cube's attacks would inflict. This condition wasn't quite paralysis, however. Though nowadays, our gelatinous cubes no longer have such an effect, which I think is a great loss. Its paralysis was very lethal before, and played to its in-lore hunting style quite nicely. As a minor aside, the cubes also lost some damage immunities through the additions. I don't think this has any real detriment to the creature as a whole, but it is something that changed. Starting with AD&D, the cubes were immune to cold and lightning, even though it is mentioned that the cold physically slows them and they have an aversion to it, outright avoiding it. In 3rd edition, the cube lost its cold immunity, and in 4th edition, its lightning immunity too. Moving on, this beastie is a creature that seemingly functions solely off of instinct. It is attracted to heat sources, moving them instinctually, as heat often signifies that living prey is there. It moves on this instinctual autopilot because it has an abysmal intelligence score of 1. This autopilot is described as mindless and only pursuing food. Once again, just like your mom. They patrol the dungeon they live in, and Roomba up anything they run over or into. This tendency is perhaps the reason why dungeon owners put them around their dungeons. They act as a deterrent, and they clean up everything. Not only that, but because the cube doesn't break down hard materials, the owner can just remove any valuable items the cube has collected inside itself. It's not as if the original owner has any use for it now anyway. It is also worth mentioning that not all gelatinous cubes are mindless. There is a notable exception being a head of the sewer workers in a city, a cube that has some intelligence. Some final notes to go over is that the cube can, in addition to sensing heat, use vibrations and scent to find creatures. How it can smell isn't really explained, however. The cube is quite lightweight, with a cube of water the same size as the athcoid being over 6 times as heavy. The gelatinous cube's primary food source isn't actually ill-prepared adventures, and is instead things like moss, carcasses, basically any living tissue will do. Finally, the gelatinous cubes divide every 6 years into 2 cubes that are only slightly smaller than the full-sized cube, with both growing back to full size in under a year. This method was made so that another stat block wouldn't have to be made for adolescent cubes. Cubes don't age, and only die by getting killed, getting into an accident, or, in my opinion, the most likely, starvation. Now that you have an idea of what the gelatinous cube is, let's make it realistic, shall we? To do that, let's outline Within Chapter 2, we'll be looking at, go figure, the issues with the gelatinous cube. We'll be tackling the chapter in sections, each highlighting a different issue: shape and locomotion, digestive capabilities, metabolism, and growth, reproduction, and intelligence. Now, for some of these, I may have gone a tad overboard in the script. I apologize if I feel a bit too rambly, but you are watching a small channel making a science video. You couldn't have come here expecting a Hollywood script. Shape and locomotion. The gelatinous cube is often described as being a perfect 10-foot by 10-foot by 10-foot cube that maintains its shape. But you see, I find this problematic. Real soft-bodied creatures in nature are all loosey-goosey and don't maintain any particular shape for the most part. This would go doubly for a creature as light as the cube. If the gelatinous cube were real, it would burn a substantial amount of energy trying to maintain its shape. Realistically, this shape maintenance as a feature of something like the athcoid is quite unlikely, at least for any extended period of time. The gelatinous cube is a mass of acid held in cube shape? Probably. Regardless, not particularly structural. A mass like that would probably bulge under its own weight, especially in the middle, compromising both its shape and transparency. But all hope isn't lost. There is a way this could work, which we'll get into later. As for their locomotion, yeah, I really don't know. It's never explained how this giant jello block actually walks around. In biology, creatures without bones or legs move in strange ways, like ambioid locomotion, typical in eukaryotic cells, whom the gelatinous cube seems to share similar traits with. In this method of locomotion, the cytoplasm of the cell is protruded into pseudopodia, or false feet. The pseudopodia can function in several ways, but that's outside the scope of this video. Another movement method is via peristalsis. This movement is similar to an earthworm, caterpillar, and millipede, where it expands itself forward and contracts itself back to the front in a wave pattern down the body's length. There's also the gastropod method of locomotion, where the foot uses muscle contraction and relaxation, plus an adhesive substance to walk. For this version of the gelatinous cube, I think that ambioid locomotion is the most likely form of motion. However, another movement method called gliding motility, used by microorganisms, may be the most lore accurate. Digestive capabilities. The gelatinous cube is seemingly a fluidic suspension within a gelatinous medium, practically a walking stomach with one-way walls. My gripe with this is that the acid here is seemingly incapable of dissolving metal, rock, wood, and even bone, strangely enough. This doesn't fit with their digestive speed at all. In fact, the cube's acid would be unbelievably powerful with the damage it does in-game. This suggests that the cube is somehow capable of distinguishing what material any given item is within it, and determining that it would be inefficient to break it down. All of this from a creature with 1 intelligence and 6 wisdom. Apparently advanced selective digestion or intricate control of the acid within them is a low IQ task. In the real world, amorphous creatures similar to the gelatinous cube use enzymes to break down organic matter specifically. As it stands now, the stomach comparison is valid in that food goes in and begins being broken down by acid. You and I have a stomach acid with a pH of between 1 and 3 that's strong enough to dissolve meat and even pit through metal over long periods, but it's slow. The vulture holds the current biological record with an acid close to pH 0, basically a living bottle of hydrochloric acid that can melt down even anthrax spores. Battery acid sits around pH 0.8. The cube, meanwhile, judging by its in-game damage, we're talking well beyond biology and into industrial chemistry. Something like concentrated sulfuric or hydrofluoric acid, the kinds of substances that can burn straight through flesh, bone, and in some cases glass in seconds. That's the only way its 6-second kill window makes sense. 6 seconds may sound abstract, but the 6-second statistic is derived from the commoner, an average non-magical human stat block, having an HP of 4 and the gelatinous cube having an acid damage on both its pseudopod and its first turn of engulf of 3d6 or an average of 10.5. On subsequent turns after a creature is engulfed, it takes 66 or an average of 21 damage per turn. This is enough to drop a human 5 times over. To put into perspective the strength of the gelatinous cube's acid, let's build a plot of acids. First, we should plot something everyone knows is our baseline, water. It has a pH of 7 and will go smack in the center. Since we were talking about gastric acids, let's map those too. Humans are between 1 and 3, we'll go with 2.5, and vultures are at 0 to 1, and we'll go with 0.5. Now let's get into some acids you may commonly think of. Battery acid is actually less acidic than vulture gastric acid at pH 0.8. You may also think of hydrochloric acid, which has a pH of 0. Now, at this point you may be thinking, well, that's it doesn't go below 0. And just like in middle school, I'm going to show you that math extends below 0. From here in, we'll be using a different measurement system to pH called Hammett acidity. Denoted with this little note, Hammett acidity is for the classification of superacids. With that new context, let's extend out our range, shall we? HCl is now moved down to have a Hammett acidity of -1, and that will serve as our reference point. Unfortunately, now we're moving into the weeds with sciencey names that aren't known to the general public, with oleum having a Hammett acidity of -14.5. Moving way further left is the seemingly rather unseriously named magic acid, with a Hammett acidity of -23. Finally on the list is an acid used in the, as of right now, recent film Superman 2025 by Metamorpho. This is fluoroantimonic acid, with a Hammett acidity of -28. Of course, that was a whole lot of background for something so simple as context, but it's important to understand how powerful the acid of the gelatinous cube is. And how strong is that, you may ask? I'd estimate somewhere around -17 Hammett acidity. Not quite fluoroantimonic acid level, but with it being capable of dissolving several people in a few seconds, it's stronger than pure sulfuric acid, and right around the strength of fluoroboric acid. At fluoroboric acid or cube acid level, you could even hold a vial of it without the bottom melting out. Attempts at containing it in a setting with the technology of D&D, it would kind of look like the scene from Breaking Bad where the roof falls out while they're trying to dissolve a body in a bathtub. Now, of course, the performance and mechanical damage and lore damage are two different things. However, you have to understand that acid of this strength isn't really a choice that the cube can make as it could in lore. It would dissolve everything it ate, regardless of composition. Some materials may not be reactive, but I personally couldn't find any acid as powerful as the cube acid that didn't react with anything other than organic materials. To further contextualize the acid strength, let's compare the cube acid to a few other in-game acids, and then show just what the acid can do in pure in-game damage, just in case you thought I was exaggerating. The acid flask in-game item deals just 2d6 acid damage, and even the spell Acid Arrow only deals 4d4, or 10 average damage on a hit, and 2d4 per turn after that. That's a second level spell. A particularly durable object, size large, has approximately 27 5d10 hit points, meaning that a gelatinous cube could in nearly 6 seconds dissolve or seriously damage an entire horse-drawn cart, or nearly the 2 horses pulling said cart at once, 2d10 plus 2 HP per horse. This damage can get even more terrifying if they really aren't fully acid inside, and there's a possibility they aren't. Because there's another way of thinking about the gelatinous cube that isn't like a lava cake, where the cake is actually jello and the delicious melted chocolate is deadly acid. This method would be small pockets of acid that the cube moves over a trapped creature. Think something similar to a lysosome, a stronger acid-resistant vesicle that is moved over top of engulfed prey. Another method is many smaller vesicles that float around and rupture like biological landmines when a creature wanders into the cube. The issue with this is that this makes the acid even more potent, whereas before one would imagine that the whole inside is acid, completely bathing the trapped creature. Now it's a small pocket of acid that is strong enough to kill 2 entire horses in 6 seconds. Though the biggest issue with the fluidic suspension idea is that the whole inside of the cube would have to be heavily resistant to its own acid or risk dissolving itself. To assist in showing the fluidic suspension idea, I'll use the best representation of the cube I can find. The film Dungeons & Dragons: Honor Among Thieves, where our jelly is entered and clearly is just acidic over every inch internally. Though that may be contested as it didn't appear to be alive, though it would be strange to have its acid amount increase post-mortem. At another look at that same jelly, it appeared to have a, gelatinous consistency throughout. Imagine the cube as one massive block of acidic gelatin, like a clear sponge soaked in acid. This would be the hardest build to achieve. In real gelatin, the material used is collagen. Of course, collagen would get instantly melted by acid. There are hydrogels in chemistry that can incorporate acids in their structure. The issue? This gel would have to be crazy resistant to the acid within, like beyond extremophile. Most gel formations would be instantly ripped apart by even some of the weaker acids, but little could resist a superacid, which would make up the gelatinous cube. The only way this kind of composition would be possible is if magic was directly used to fortify the cubes, meaning one well-placed anti-magic zone would be enough to reduce the cube to a puddle. The cube apparently eats flesh and other random nutritious tissue it finds strewn about. But let's be real, how often are creatures large enough to sate the rather massive gelatinous cube just wandering down into the dungeon where the cube patrols? Pair this with long time between meals and with its insistence on holding its shape constantly, and even moving around, and you have a creature that just bleeds calories. The cube weighs several tons. Even moving itself down the hall would take thousands of calories. If it doesn't eat daily, its metabolism must be slower than molasses, or it somehow procures some sort of alternate energy source, like chemosynthesis, arcane osmosis, or perhaps the legendary Dungeon Master Fiat. Tasty. Now, there is actually a very valid idea for hibernation or stasis between meals. However, this would mean that the gelatinous cube would be unable to hold its shape for 3 meals, and would rely on waking up and returning to their normal shape before a creature can notice them. This, however, is very unlikely, as the gelatinous cube has a passive perception of 8. Additionally, some of the raw energy of consumed prey would be lost to replace the acid used. The gelatinous cube would work like a mini refinery, turning some of the prey into raw chemicals. How it can take a body and formulate a superacid out of it? I'm not even going to pretend I know how or if that would be possible. Growth, reproduction, and intelligence. Somehow, someway, the gelatinous cube has nearly no mind and no intelligence, and yet it maintains control over its shape, size, digestion, replication, which is similar to single-cell organisms, weight distribution, movement, and replacement of used superacid. Perhaps it's capable of functioning so well with no brain because it can function instinctually, or in a manner even more similar to unicellular organisms. The thing is, it's obviously not unicellular. I mean, it's pretty big. This means that its exterior cells make up pretty much all of the controls the cube needs all at once. This limitation is because, as previously stated, the whole interior is acidic, which means no cells. The exterior would have a dedicated wall to trap the acid in, protecting its fragile outer gel. So all of the mechanisms are held in the tiny bit the cube has on the outside. I strongly doubt that the paltry sum of cells on the outside of the gelatinous cube would be capable of controlling all the aspects of the cube I mentioned before. Next on the list, the reproduction. In the lore, the cubes have some funny limits on the reproduction, despite reproducing asexually. You see, because the gelatinous cube functions like a giant single-celled organism, it could theoretically reproduce insanely fast, the speed of which would be determined by the amount of food available. Within many bacteria and unicellular eukaryotes, binary fission produces 2 daughter cells that are a bit smaller than the parent. As written, the gelatinous cube follows this quite well so far. Now, the time it takes for the daughter cells to grow back, called the generation time, is heavily dependent on the nutrient available, the temperature, and the environment. Basically, more food equals less time to split. There is a limit though. Pushing too fast could result in cells forming improperly. Cells follow a rough checklist to determine if it can reproduce. 1. The cell must be a certain size before attempting to undergo fission. 2. The cell must have the energy required to reproduce. 3. The cell can't have any fatal mutations or broken chromosomes. 4. The environment can't be too crowded, dangerous, hot, cold, and a few other things. Not fulfilling these conditions could result in the cell just not dividing. For both the unicellular organism and our gelatinous cube, the biggest hurdle is nutrient availability. This is far more so for the cube because of the previously mentioned factors. The cube must burn substantial calories to move, hold shape, synthesize acid, reproduce, and generate gel walls that are capable of resisting its own rather powerful acid. Chapter 2 Conclusion. The gelatinous cube, as it exists in game, seems like a biological implausibility. It has no real sensory organisms, no plausible metabolic regulation, and no way to control its digestion with any nuance. It's less a living creature and more of a walking, or maybe sliding, stomach with no brain and no survival strategy. Additionally, it doesn't somehow melt literally everything it hoovers up, with the clean environment almost certainly cluing in any competent adventurer, and even animals, of its presence with a trail of devastation, or perhaps cleanliness, it should logically leave behind. And yet it survives. Somehow. So how could we make it work? To determine that, it must undergo a... Siphonophores are highly polymorphic and complex organisms. Although they may appear to be individual organisms, each specimen is, in fact, a colonial organism composed of medusoid and polyploid zooids that are morphologically and functionally specialized. Wikipedia. To most people, the word siphonophore means nothing. Even among biology fans, it doesn't come up often. But there's one member of the order you've probably heard of, the Portuguese man-o'-war. Unlike your favorite jellyfish or octopus, siphonophores aren't single creatures, they're colonies. Imagine a swarm of identical clones, each one specialized for a specific task. Some sting, some digest, some float, and others move. It's like a living office building with perfect task delegation. It's weird, but it's very efficient, which is exactly why I'm rebuilding the gelatinous cube using siphonophore biology, because it's scarier than an acid blob. A sentient colonial organism with limbs, nerves, and strategies. Within the siphonophore colony, the division of labor is very clear, though we have yet to determine its specifics with the gelatinous cube. Here's my idea of what this should look like. But first, a quick break from voiceover me to editing room me. I realized I was a bit unclear about the revised gelatinous cube and its supposed place under the order Siphonophorae. This video is speculative biology. That much should be obvious, but it's also speculative evolution. Now, any siphonophore could theoretically evolve into a cubic shape, but remember, they're still cnidarians, and therefore aquatic. The sharp-eyed among you may have noticed that 99.99% of your encounters with a gelatinous cube are on land, and notably, not underwater. In my interpretation, the gelatinous cube isn't a siphonophore itself, but a distant relative, roughly 1 million years removed from the Portuguese man-o'-war and its kin. Over that time, it would have lost its siphonophore order status while retaining its cnidarian phylum roots. Its taxonomy might look something like this. Phylum, Cnidaria. Class, Pterahydrozoa, or land hydrozoans. Order, Coloniforms, or colony-formed creatures. Family, Pterasiphonidae, or land siphon family. Genus, Pterasiphon, or earth siphon. Species, Pterasiphon amphibius. Sure, the namings are a little on the nose, but that's fine. Anyway, back to your regularly scheduled programming. First up is the structure of the cube. As previously stated, the cube may be light for its size, but it's still not light. The cube would weigh a significant amount, which would almost certainly cause the center of it to bulge out convexly, breaking their stealth and making them look like a squished marshmallow. That would be the case too with our siphonophore cube if I didn't include structural zooids. These structural zooids would be like a bunch of fibrous, gel-bound tension lines keeping the shape mostly a cube. And even if the shape fell a bit, the zooids are capable of moving their form to straighten up. A secondary idea can be added onto this for additional reinforcement, shape maintenance via hydrostatic pressure within internal chambers, though this is an optional addition. Next is locomotion. Because most of the sides of the gelatinous cube are in contact with the surface, 4 of the sides of the cube are almost solely dedicated to pulling the cube along, like millions of tiny, sharp legs. This many points of contact would allow for the burden of propulsion to be divided between the sides, saving on energy. Beyond just the cube's hunting strategy, this gives a further reason to maintain contact with the walls and ceilings of dungeons, keeping the original vision of the gelatinous cube alive. Hunting and digestion in our reconstructed gelatinous cube follows a process that mirrors siphonophore biology, specifically borrowing from the Portuguese man-of-war. While modern Dungeons & Dragons cubes are armed with blunt pseudopods that smack a creature and melt it with acid, our reimagined version features a familiar, sinister mechanism. From within the cube's gelatinous body, a long, flexible pseudopod lashes outward. Upon contact, it wraps around the target, but this is no ordinary appendage. The pseudopod is lined with hundreds or even thousands of microscopic venomous barbs, which simultaneously embed into the prey and inject a neurotoxic, paralytic venom. These barbs serve two purposes: immobilization and traction, allowing the cube to reel the victim in with horrifying efficiency. As the prey is drawn closer, likely already paralyzed, it reaches the outer membrane of the cube, an area lined with sensory appendages that detect touch and movement. These trigger a cascade of grasping tendrils, which pull the paralyzed creature deeper into the organism. Eventually, the prey is passed into an internal chamber where enzymatic digestion begins, dissolving flesh and soft tissue into absorbable nutrients. Any material that resists digestion, such as bone fragments, metals, or certain magical items, are excreted back through the body and left behind as waste. This mirrors the function of the man-of-war's gastrozooids, and further supports the concept of specialized internal zones within the cube's structure. This design allows us to bring back the paralysis on contact feature used in older editions. As said previously, until 3.5e, the gelatinous cube could immobilize its victims, and here, we found a plausible biological justification. Much like the man-of-war's tentacular palpons, which deliver venom and drag prey towards digestive zooids, our cube's pseudopods act as both whips and winches, envenoming and consuming anything unlucky enough to make contact. Onto our sensory organs. This can actually go many different ways, or all of them at once. The cube could use its sensory organs to detect a variety of things, including, but not limited to, heat, pressure, vibrations, or, due to the scale of the cube itself, something similar to many tiny compound eyes, obviously seeing light. The cube's skin could house thousands of pressure-sensitive nodules, like a catfish or star-nosed mole, feeling motion in all directions. Let's talk energy strategy. The original cube would have starved within a relatively short time frame, though that is only an educated guess. Our updated cube will use a combination of chemosynthesis and a slow metabolic rate, allowing for a great length of time between meals. This cube could even have a hibernation state, where it flattens itself to conserve energy and allow for it to trap creatures within itself relatively quickly. Alternatively, it could just seal its internal chambers and use its structural lines to hold itself up, as its predecessor did. Additionally, its xenobiology is, in and of itself, more energy efficient. Previously, the cube burned energy just to exist. Movement, shape retention, acid synthesis, self-protection, and reproduction. But with our new, updated biology, most of these problems are drastically reduced. For the movement, it actually has an explanation on how it moves to begin with, and it includes using every surface available to move. We just covered it being able to hold its shape. It no longer even uses its weird acid system, so no energy is required for generating acid, nor resisting its own acid, and its reproduction will be covered next. We could have our cube reproduce via asexual budding, wherein a zooid, or potentially a small mass, breaks off the main body and begins to grow as it consumes biological matter, allowing for the creation of more zooids. Potentially, there is the possibility of two colonies, two cubes, meeting and forming into one larger cube. With this mechanic, there could be nearly no limit other than structural integrity when forming larger cubes. This could potentially bring the gelatinous cube from CR2 to wherever you need it, cannon fodder to Colossus, level 1 crook versus level 99 mafia boss, if that joke is still relevant. Lastly is one item I think wouldn't make sense to keep and didn't even make sense with the original creature: carrying items within its body. If the gelatinous cube carried any items it couldn't digest around, it would be very easy to spot, not fitting with its ambush/opportunistic strategy. I didn't keep that for my reconstructed version for those reasons, and some others too. Though, feel free to keep it if you use this idea in your campaign for whatever reason. And with that, our cube is complete. It does everything the original did, just with a better explanation, a new biology, and a neat little bow on top. Though, calling it gelatinous now might be a stretch, so maybe I did fail to properly reimagine the gelatinous cube. If you thought this was a good take, subscribe for more creature reworks, weird biology dives, and other sciencey ventures. If you thought it sucked, fair. I'll try harder next time. Got ideas for future monsters? Toss them in the comments below. Either way, thanks for watching, have a great day, and I'll see you next time.